DSMA-4 reading bar graphs. Let's take a look at this image that we have on this first slide, and it gives you kind of a little insight as to what you're looking for on a bar graph. And one of the things we want to know is that we have a title. So you want to make sure that your bar graph has a title. And then we have two axes here. We have this horizontal axis here, and then we have this what's called a vertical axis there. These should have labels on them. You want to know, what is it measuring? What is it describing? All right, so sometimes you have numbers, and sometimes on the vertical rise, and then on the horizontal, you may have some type of description of what it is you're measuring. So it says on here, bar graph uses bars to show a picture of the data collected. So not only will you be looking at bar graphs, you want to make sure when you look at a bar graph that it makes sound sense. And in the same sense, what if you could take your work, your data set from the hard work that you're performing, and you can make a bar graph and do a presentation. Perhaps you're trying to get that raise at your job and you need to do a bar graph that depicts your information. You want to make sure that your data set is well represented and that it is easy for your audience to interpret and understand. All right, so bar graphs are important. Let's take a look at this next graphical image. Now, this is an image of what's called a horizontal bar graph. It does have a title, Major Storms Making Landfall. On the horizontal axis, it has numbers 0, 10, 20, 30, 40, 50, 60. And then on the vertical rise, it has October, September, October, July, June. So I actually would probably put labels on it, not just list the items on here. So I would probably say months. And then on the very bottom, I would probably say the number of major storms. So let's read the description here. It says the bar graph shows the number of major storms by month that have made landfall in a region between 1851 and 2005. In which month did the most major storms make landfall in the region? So you're looking for the month. Most major storms make landfall in the region. So you want to look for the bar that has it's the longest bar in this case. And this would be the month of July. So the month of July has the most major storms that made landfall in that region. All right, another question that could possibly be asked of this would be, for the month of July, approximate the number of storms. So if it said something like that, what you would do is take the month of July, the bar, and I'm going to do an imaginary vertical line so I can kind of see, not quite vertical, but kind of see where it is. So I know it's below the halfway mark. So I may say that in this case, approximately 52 major storms made landfall in the month of July. That would just be an idea of how this question could be asked differently. For this vertical bar graph, it's showing that it is tornado deaths in the United States. And on the horizontal, it lists each of the months, January through December. And the height is in numbers 0, 5, 10, 15, 20, 25, 30, the number of tornado deaths. So it has a description on it also, so it covers everything for them not being labeled. The bar graph shows the average number of people killed by tornadoes during the month of the year. Approximate. This is important because it says approximate the number of tornado-related deaths that occur in July. So approximate means we may not know exactly what it is, but we can estimate it. So we're looking at the month of July, and we want to know approximately how many tornado-related deaths there are. So since the height of that bar, it looks like it's about right here. I'm placing it on the horizontal. This looks like it's about a 2, since it's below the halfway mark between 0 and 5. So and it does say type in an integer here. So I would actually place in the number 2 as my estimate or my approximation. All right, so then we have another horizontal bar graph. It says the horizontal bar graph shows the population of the world's largest cities, including their suburbs. Name the city with the fourth largest population and estimate its population. So we want to know the city with the fourth largest population. So I'm going to go with the first largest population, the longest bar graph here, the second, and then the third. So the fourth one would be right here, and it looks like we have Mexico City would be the fourth largest population. So I'll select that. Which city has the fourth largest population? Mexico City, Mexico. And then it says to estimate its population. So I'm going to go to the end of the Mexico City bar, and I'm going to try to do another imaginary vertical line here so that it gives me an idea of where to estimate at, and estimating its population. So I would say estimate is about like 23. Remember, this is measured in millions. So 23 million would be the population. Right, so look at the edge of the bar. Go ahead and draw a line all the way down to the population axis. And you know it's above the 22, so it must be about 23 million. Again, this is just an estimate. So they provide us a table here that says fiber content of selected foods. The first column is the food labeled A through F, and the second column is grams of total fiber. All right, so the food is what you would have labeled as the horizontal axis. That would be the axis that goes side to side like this. This would be your food, and you'll label the A through F. And then the vertical axis here would be your numbers of grams of total fiber. All right, so I'm just going to see if I can sideways here for a second. Grams. This is your grams of total fiber. All right, so that is how it should be. And it says use the information given to draw a vertical bar graph. So when it says choose the correct graphs, you know that we can automatically eliminate A and B because those are horizontal bar graphs and we want the vertical bar graph. All right, so then we take a look and see, remember the height on the grams, if you look at A, for instance, let me just put A up here on my little chart. A has a height of 2. Let's see, we're going all the way up to, it looks like 5. So 1, 2, 3, 4, and 5. Sorry, not very good, but good enough for now. All right, and so the height of just A is going to be 2 because it says grams of total fiber is 2, getting this from my chart. So if I wanted to, I can just say from here to here, that's a height of 2. And then B is going to be a height of 2.5. I'm getting that from, again, the chart. So it's in between 3 and 2. And I'll call this B. So if you take a look at B, the answer, you can see that the height of that bar is about 2.5, 2.5. But if you look at this other bar for the B on the answer choice C, this is at 3.5. So the height on B is too high on this choice C. So that's telling you your answer is going to be B. And that is what your bar graph should look like. All right, so this is actually called a broken line graph. It is made up of line segments that are connected. So we're not looking at a bar graph, we're looking at a broken line graph or a line graph. And it says on here, the line graph shows the average number of goals per World Cup game during the years shown. Approximate the number of goals per game in 1994. And it says on here, the average number of goals per game in 1994 was approximately blank, round to the nearest 10th. Wow. So they want us to round to the nearest 10th. So if we take a look here for the year of 1994, we're going to go vertically up for the year 1994 till we get to our graph. And it looks like it's contained right here at this point. And what you want to do next is you want to move to the left until you get to the vertical axis. So I'm going to draw my dashed line again. Again, we're going to the left. And this is not quite, but it's going to be about a 3.5, right in between 3.4 and 3.6. So I would approximate this to be 3 5/10 or 3.5, as students would say. Again, you find the year that you need on the horizontal axis, which is 1994. Go vertically up until you touch your graph, in this case, the line graph. Hold that point and look to the left of that to see what the height is of it. So 3.5. So we're looking at another line graph that shows goals per game average for a sporting series during the years shown. During what year or years shown was the average number of goals per game less than 2.3? So we need to find it where it's less than 2.3. So let's look and see if we can find about the vertical axis where this 2.3 is. So if we start with a 2 and the next jump is to 2.6, it looks like it's increasing by 0.2. So this is probably a 2.2 and a 2.4 here. So I'm looking for anything below 2.3. So anything that is below this line right here, if that helps you out. So that would leave us with this right here and this right here, which means we need to find what these years are that define less than 2.3 on the goals per game. All right, so if you take a look on here, the years jump from 1981 to 1989. And if you look, each little tick mark on there increases by an increment of 4. So 1981 plus 4 would give you 1985. And 1985 plus 4 will give you the 1989. And then again, you add 4 again and keep going. So from 1997 plus 4, that will give us 2001. All right, so 2001 would match on there. So during the years, that would be 1985 and 2001 would be the 2 years where the average number of goals per game fell less than 2.3. Right, so we're looking for those lowest values that fall below a 2.3. And then again, you had to find out what year matched for each of those little tick marks in there. And let me rewrite this one more time here just so you can see it a little better. And this is 2001 for this year here, and this right here is 1985.